Welcome to this Architecture Today webinar with Schu. From marginal to mainstream, can passive house construction become the new norm? In a moment, your event chair, Ruth Slavid. But first, here's Schu UK's Commercial Director, Sean Butler.
Welcome to the latest in our series of 80 Schu webinars. In today's webinar, we will consider how passive house construction can become embedded into mainstream architectural projects. We know that increasing numbers of local authorities have adopted passive house, with some using it as an alternative compliance standard. But what will it take to pick up the pace? You are about to hear from 4 experts who will share their experience delivering passive house developments, both within the education sector and larger scale residential developments. What were their particular challenges in achieving the very best results, and how have they managed to stay true to the passive house principles of each project? This is an issue that Schu are very well placed to bring their experience and expertise to bear. We manufacture a diverse range of highly insulated and airtight facades, energy efficient ventilation systems, as well as door and window systems which are certified and approved for use on passive house projects. We believe that Schu is one of the sustainability pioneers within the construction industry. But we know we don't have all the answers, so I'll be extremely interested to hear the presentations and discussion today. Thank you once again for joining us. I'll now pass you to Ruth, who's chairing this event.
Thank you very much indeed, Sean. I'm delighted to be chairing this today because it is such an important subject and we have such a great range of speakers. We will be hearing shortly from Matthew Traub at Allies and Morrison, speaking with Gwilym Still from Max Fordham, who will be talking about a project that they have worked on in Cambridge. We'll also be hearing from Anne-Marie Fallon of Architype, who will be talking about their work on schools. But first of all, our first speaker is Adam Booth, who is project architect of Field and Clegg Bradley Studios. And he is going to talk to us about a project which is outside the mainland, outside the UK, but actually not very far away at all. Over to you, Adam.
Thank you for the invite to come and talk about our proposals for South Hill in St Helier, Jersey. It's proposed to be a 150 plus apartment private sale scheme in the former quarry site at the end of St Helier town centre. It also includes some additional amenity through the retention of a listed building and a ground floor cafe and an upgraded park next door. We're Field and Clegg Bradley Studios and we're the lead designer for the scheme. We're a practice, for those of you that don't know, that cover all manner of different architectural sectors, including schools, higher education, cultural buildings, master planning, and even some charity work abroad. And we've got offices in Bath, London, Belfast, Edinburgh, and Manchester, which is where I'm based. So therefore we're a UK practice and award-winning practice, including our Accordia scheme, which was awarded the Sterling Prize. At the base of our design, it has always been an eye on low energy design solutions in terms of our buildings, and more recently we've been striving to integrate passive house into new schemes that are coming forward since the kind of declaration of climate emergency. And we've also used our in-house tool, which we've made open source, called FCBS Carbon, which enables us to analyze embodied carbon and operational carbon at an early stage. So as I mentioned, this aligns with our declaration as part of the climate emergency and being one of the founding members of the UK Architects Declare. And this leads us into South Hill, really, which is a relatively new project that came in last year, and obviously having strong aspirations to make this a design scheme that is responding and addressing those missions that we've set ourselves, and doing that with a client that is interested in doing so also. The client is Jersey Development Company. They are part government owned and therefore have a very strong mission and response to the climate emergency and environmental strategies that they want to employ on the island in setting a new benchmark for housing with this scheme. And we're supported on a core team by Gillespie's, Waterman and the Tude in terms of landscape, engineering and passive house respectively. So the site sits in pink here. It is surrounded by the mount and in the former quarry that is kind of renaturalised, and that green fringe traces up the glassy field, which is this park lawn that runs up towards Fort Regent, which is a listed place. This is then bound by harbour walls and sits at a kind of mid-level between that fort and upper level and down to the harbours below, which again are listed places. On top of that, it then also sits within the working harbours and the industrial land reclamation beyond in La Colette, and amongst a mixed scale of buildings in terms of domestic, mid-scale and sort of newer, larger scale pieces. So quite a difficult place to respond to in terms of satisfying all the different contextual pieces that exist there, but something that we've enjoyed doing in a landscaped fashion, given it's bounded by that rock face and well naturalised in terms of its greening. And therefore we see it as being not necessarily an urban piece, as you might get in Jersey Town Centre, St Helier Town Centre rather, and actually more of a landscape piece that evokes the thoughts and feelings of the quarry, the rock face, and it can be something more embedded within that natural landscape and greened up and to renaturalise and soften the edges as is at the moment. So our response to that was to reinstate the quarry or the quarried landscape, if you like, and start to recarve. And we did that. The first move was to bring through the harbour in front of the site and create a courtyard space that retains the listed building and starts to open itself out at the back to bring in that view. Then it was about creating an axis on the key views, so bringing in Fort Regent above the glassy field, as it's known, and down to Mount Bingham, and having that creation of 3 buildings around a courtyard and listed building. Then we shaped those buildings and set them back to allow for circulation and public realm across the front of the site, around the buildings and through the site into the park. We then set some of the buildings down on the front to respond to height and create a hierarchy across the site, and also in relation to that backdrop of trees to the rear eastern boundary of the site. We further manage that height by then introducing setbacks at the upper levels, which also enables us to offer terraces to the apartments at those levels. The architectural character is then added through an overlay of quarried horizontals, if you like, which start to offer space and external amenity to those apartments through balcony spaces. And then the character is then developed through a shifting and folding of those balconies and edges and facades to evoke the geological formation of the granite and rock faces from the mount itself. These are then softened through a series of planted pieces through green roofs, planters to the balcony edges, and obviously the landscape is the courtyard and replanting of trees to the tree line beyond as well. So this led us to our current scheme, which is pre-planning, I should say, and involves 3 buildings. So the Crescent building to the back, which obviously maximises that westerly view, which is the key viability driver for the project in terms of getting apartments to maximise that view out across the harbours and the bays. And then 2 smaller buildings that frame the site and reveal the open courtyard and Belvedere moment, if you like, from the front, also to that view. The North Pavilion has a ground floor cafe, which spills onto a sunken terrace, and that wraps up and relates through to the park, which is intended to be refurbished and re-landscaped into a sculptural play park, creating more of a destination piece and link back from the town and Fort Regent area. In terms of materiality, we're obviously building on the reference of the rock and the granite, but looking at something more contemporary in terms of a GRC or a pigmented precast or terracotta, and how we can then plant up those facades and faces to soften them with landscaping to renaturalise the quarry as it is at the moment. So some views of that this is a view from the Victoria Pier and or boat approach maybe. Seeing the rock bringing itself around, hugging that southern edge, and then the pavilion sitting as sister buildings to that rock face. And then looking back down the glassy field from Fort Regent on that axis where the buildings are separated to get the view through, and the bigger rear buildings sitting in amongst that backdrop, and the front buildings sitting lower down to have that relationship of height to the mount on the closer views. Inside the courtyard, this is a view of the rear building, and as you can see, it's got that architectural character from the geological shifts, if you like, across the facade, the folding and cranking of the balconies. But as you can see in behind that, there's quite a simple cranked thermal line, which is recessive in nature, and allows us and alludes to that form factor in terms of the passive house design. So in plan, you can really start to see that some more simple thermal line sitting behind the cranked and shifted balconies, and the real mix of apartments that we've got here. There's a strong a 3-bed contingency. It's not just 1 beds and 2 beds, and they are available across all buildings at all levels to give a real mix for the market. And obviously in this pandemic, or hopefully post-pandemic world, we're still thinking with an eye on that in terms of how we can respond to people living even in a standard kind of relatively small 1-bed apartment, and how we can offer them different areas to touch down and work and dwell, in a lockdown situation, whether it be in the bedroom, in the lounge, on the balcony, or in sort of in between spaces on breakfast bars and the like. The character of those apartments obviously driven by the view out, and we've used the kind of thick thermal line envelope, which we've developed with the Passivhaus strategy, and sleeved it with a timber lining, which kind of reveals that. And also, again, maybe we can offer a window seat in that window to offer another place to dwell within the apartment, and with the balcony then obviously offering itself the big panorama view out over the bays. So in terms of Jersey targets for the environmental and climate agenda, they've set out a strategy to get to 2030, of which our project obviously sits inside. And they have some quantifiable targets for operational energy. They want a plus 70% improvement on current trends. In terms of embodied carbon and fabric, it's a bit less quantifiable, but there is ambitions to improve the energy performance of buildings through fabric and technical design policies. And that's where we've started to look at bringing our own quantifiable targets in to kind of support these carbon neutrality strategies. So in terms of embodied carbon, we've used our in-house FCBS carbon tool and set ourselves against current standards. So, maybe a building that we or others may have designed without a mind on embodied carbon or material use. And then we've set our goal against LETI and the RIBA climate change challenge for 2030, and that being it's a building that is less than 500 kilograms of CO2 per meter squared. And currently, we think at this early stage we can sit, on the threshold of the 2030 RIBA challenge, and given that we'll be delivering in the 2025 zone. Similarly, with operational carbon, we've set ourselves against current standards, so Part L or Part 11 on Jersey, and how we can seek that kind of 70% improvement. And that leading us to believe that we then should be targeting a passive house and LETI kilowatt hours per meter square per annum target. And again, early studies showing that we think this is something that we can achieve. So some of the methods that we think across the building will enable us to do that is obviously that thick thermal line, simple form that I've already mentioned, and within that having the triple glazed windows to minimize heat losses, but with openable windows for purge ventilation and cooling. And then in terms of the balconies, obviously they're thermally broken and offer that solar shading, whilst integrated finishes to that balcony structure enable to reduce material use. Servicing, MVHRs to provide background natural fresh air, water saving utilities, zero combustion and all electric to all fittings, and heating being fed off an air source heat pump on an ambient loop through the buildings and then boosted in the apartments for where it's needed, with a view that heating should be minimal given the thermal efficient and airtight external walls. And then just stepping away from the buildings into the kind of wider picture, really, we also frame our designs within a One Planet Living framework, which has 10 categories, of which one is zero carbon, but also 9 others that cover other areas, from health and well-being to land and nature to travel and transport. And this enables us to also look beyond the private sale of the apartments, and also think about the public interfaces and engagement with the site, given that the ground floor cafe, listed building, and the park, which form part of the proposals too. So we believe with the planning requirement of BREEAM as a design-based tool, the holistic look at the site and proposals in general, using the One Planet Living framework, of which zero carbon being a focus, to give that holistic approach. And then also plus the overlay of Passivhaus as a delivery-based item, we should really get a real comfortable feel on having a sustainable and exemplar piece of architecture. So working with Etude, we've contextualized the building in terms of how it sits against Passivhaus requirements. Maybe not the best in terms of, given that it's hugged on the southern face by the Mount Bingham in terms of its context, and obviously wanting to maximize that westerly view out, which is at risk of overheating, for example. But working with them and PHPP modeling the scheme from early stages to try and get to something that we think is achievable. So in terms of form factor, mentioned that simple thermal line earlier, but pretty good in terms of the rear building, in terms of being below the kind of 2.0 threshold, given the amount of density that is in that building. The pavilions being slightly lessened in terms of where they sit, but still below that 2.0 factor. So giving us a good sense that this is something we should and can target. And the key tension really for us has been sat with the glazing. You know, architecturally and in terms of viability, is something you want to maximise to get that view, but not necessarily to the facades that can potentially suffer under Passivhaus standards. So aiming to achieve Passivhaus Classic across all buildings. This initial assessment by Etude and the PHPP model led us to believe that the west elevation could have 30% glazing, and the pavilion buildings, given the reduced form factor, could be 15%, which is obviously slightly less generous than we may have wanted. But we accepted the challenge. We started to model that in some design scenarios against the 1-bed and the 2-bed typical units. Started to understand how we could break down that glazing against what we wanted to have in terms of doors onto balconies and then windows from habitable spaces, and how those modules might be replicated across for efficiency. And where we ended up, obviously, is a departure from where we started. So, you know, getting rid of the floor to ceiling full height glazing, which is obviously a benefit in terms of Passivhaus and threshold details, but also having to reduce down the ceiling height of the window, if you like, and the width, which is slightly more at odds with the viability of the scheme. Similarly, in the living area, giving more of the ratio to the living space as the key primary habitable space, but still reducing down that head detail and also the width of the window in general. Then the other challenge was then to also look at the MVHR being integrated on the external wall, given the heat loss that the ducts can create. And that was another challenge that we took on and started to look at how we could utilize a piece of joinery that could also double up as storage and contribute to kind of planning requirements, and how that could sit within the sleeve timber windows as a timber piece. Unfortunately, that was at odds with daylight sunlight and the Passivhaus modelling, and there were some failures in there in terms of daylighting, and also the viability of the scheme in terms of that west elevation requiring an uplift in glazing ratios. And what we found upon reassessment, with more detail coming forward as we move into stage 3 pre-planning, is that the rear building, given its good form factor and density and other kind of strategies, we could increase that western elevation and retain the northeast and south as they were, to bump up the glazing ratio. However, on the pavilion buildings, given that they were so constrained before, we've now looked at a Passivhaus low energy building standard, which has an increased space heating allowance, but still an improvement on the Part 11 or Part L current standards. And this has really enabled us to push those glazing ratios up to achieve the viability that the client needs in terms of the apartment sales market, but also addressing the failures that we were having on the daylight sunlight. So going from the sort of second iteration of the apartments, if you like, we've revisited them again and found that the increase in height and width of a window in the bedroom starts to balance the Passivhaus Classic on the rear building and the low energy building on the pavilion buildings, whilst also, you know, boosting the sunlight daylight assessments and the viability of the apartments. And also again in the living room, so being able to shift from this slightly meaner, more ordinary, I guess, glazing and door layout to an enhanced and height and width on the doors and the window, and moving that MVHR to the party wall and to still be integrated on the external wall. So what we found really is that the most important kind of themes to consider early on is how the glazing and the balconies interplay in terms of, you know, optimizing solar shading, overheating, maximizing that viability of view, and also, you know, the Passivhaus requirements of heat loss and heat gain. And that obviously depends on the plan layouts as well and the servicing strategies. But I think for us, the biggest learning curve that we're maybe not always afforded is time for this non-linear process to come back round. You know, we're on our third probably iteration now to try and balance these things that are all competing with each other, but starting to get somewhere that is hitting that sweet spot between overheating, daylight sunlight and Passivhaus, in all couched within the bigger picture of viability for the client. And ultimately that requires collaboration and understanding to enable that, and it's something that we've been lucky to have with the team and the client that we have for this project. So thanks for listening, and hopefully that was of interest, and look forward to some questions.
Thank you very much, Adam. We've got lots of questions coming in, but I'm only going to ask you one now, and then we'll go to others later. And I guess it's around the I mean, I've no idea about this, the awareness of Passivhaus within Jersey, and as a corollary, how much you feel that this will be, do you have an understanding of how much this will be a selling point for the apartments, and maybe this allows them to be sold for a bit more, and does that pay for some extra costs?
I think it's an interesting question. I think we're all sort of getting to grips with Passivhaus as an industry, so I'm sure, you know, beyond the industry, it's still quite a new thing to a lot of people, but it definitely obviously does contribute to the market value in setting a standard, and obviously being able to have something certifiable, which I think is one of the key benefits really for us, in terms of it's something that is delivered and, you know, quantified, and it's not just something that is a kind of checklist beforehand. It's a definite pass and fail. But I think in terms of, you know, Jersey, it isn't mainland, it isn't UK, and they may be slightly behind in terms of their policies and their kind of uptake on things. But saying that, they have got their carbon neutral strategy out there, and I think we're just trying to support that really, and upskill and acknowledge ourselves and the client and the island itself in terms of that residential market.
That's great. I think it's really good to see a project which I suspect a few years ago people would have looked at a scheme like that and said, lovely, but you'll never do that in Passivhaus. And it's great to see that you're actually doing it. And if that's extending our ideas of what Passivhaus is for homes, of course, another area where we have been extending it is beyond residential, particularly into schools. And particularly, I know that Architype have been a pioneer of this and are doing some really interesting work now. So I'm really pleased that our next speaker is going to be Anne-Marie Fallon, who is an Associate Director of Architype and is going to let us into seeing some of the most interesting work they're doing now.
All right, thank you. Hi, everybody. I'm going to give you a little bit of an overview of Architype's work in Scotland and how we're looking at implementing Passivhaus and EnergyFit in some public sector buildings. So who are Architype? Well, we're a practice that has a focus on sustainability for around 37 years now, and the last 15 years or so has been specifically driven towards Passivhaus projects, utilising that as a really powerful methodology, quality assured methodology for our building delivery. We've 3 offices. Our most recent office opened in Edinburgh around 3 years ago, and I'm an associate director in Edinburgh, and I've been involved in the development of the Edinburgh office over the last 3 years. We also have a consultancy arm called Perform Plus. So we wear both our architecture hat and our consultancy hat, looking particularly at building aftercare, post-occupancy evaluation, building physics and other types of hydrothermal modelling, and just building and occupant health, really. Passivhaus, many people are quite skeptical of Passivhaus. I hope to kind of demyth some of that with you today, like our other speakers. And this is just an example of a kind of range of our projects and typologies to illustrate really that Passivhaus can come in all shapes and sizes, and it really is about a building physics driven approach to design. Also really important to us in Architype is post-occupancy evaluation. So for the last 10 or 12 years, we've been going back and revisiting our own projects, learning lessons learned from our own post-occupancy evaluation, as well as undertaking post-occupancy monitoring and soft landings on other schemes. And we've been involved in various UK-funded studies to external peer review as well. There's a huge amount to consider just generally in educational design, and a lot of these come to the fore as we're now looking at a climate emergency situation in relation to energy consumption. And we'll touch on some of these today as I show you 2 kind of key examples of this in terms of new build and retrofit. But you'll see a number of themes there that have been recurring over the last year in particular, regardless of whether it's a Passivhaus project or not. But the big challenge, I think, is, and the big enabler really for us in Scotland has been around some of the policy changes and the policy ambitions set by government and local authorities. But if we set a target about being net zero carbon by 2030 or 2045, we have a theoretical understanding of what that is, and we can model in design terms what that is. But the reality of that, and this is where there's a huge, huge risk to the industry and to our target emissions, is the performance gap that will prevent us getting there in reality. So, you know, the unregulated energy demand, the poor quality construction, the lack of understanding on how to deliver kind of robust set of thermally and, you know, air tightness proof details will be a big, big challenge to us. So on paper, we'll look like net zero carbon, but, you know, I think it'll be terrible post 2030 in reality if we haven't really met that. And we still have time to try and achieve that through our projects. Passivhaus Trust and Passivhaus generally as an energy standard provides a really quality assured methodology to achieve that in our view. And why would we be skeptical or cynical about trying to design better quality buildings? I mean, I often use the analogy of a car, which is ironic in the current circumstances of trying to be greener. But if you had a car and the air conditioning didn't work or the draft proofing was failing around the door, you'd return that car to the garage, or, you know, at the very least you'd get it fixed. We design buildings and we don't design them as fit for purpose items or quality pieces of infrastructure. And really, we should all be demanding better from ourselves as clients, as design teams, as the industry to deliver more high quality buildings that will create significant emissions savings. And how we do that is through a collaborative effort. And we know that the construction industry can be set up in a bit of an adversarial manner, but what we are really looking for is a new way forward, a new normal, as we've been used to hearing over the last year or so. So how do we approach school design? But it's a very cyclical approach. It's very process driven, and we really integrate the PHPP or the Passivhaus design tool within that REBA workstage process. And we know that the plan of works is leading us towards more compliance checking in sustainability targets anyway, but I think it's really embedding that into our workflows that is really, really important. So everything from defining the brief and setting up the right level of communication with the right people at the right time, following that all the way through to commissioning and post-occupancy to then feed into the next project. And it's that feedback loop that's really critical to us. A real enabler in Scotland has been the Scottish Futures Trust response to previous government-funded school programmes, and with the current one, the Learning and State Investment Programme. It's an outcomes-based programme that essentially links your energy target, seen in bandings here on the right-hand side, to your energy outcomes over a 25-year period. So local authorities will have to report to government on those performance targets over that period in order to ensure fully released funding portions for energy and quality, which is really, really powerful and a great enabler for better quality buildings. And just as an example from a couple of our own projects, how we're more than exceeding that in projects that have been built over the last 10 years that we've been monitoring, and 3 examples here of our schoolwork in Scotland, where again, just at REBA stages 3 and 4, our design intent is achieving well below those targets. So an A+ on that banding. And we're going to go into a bit more detail on Curry shortly. Of course, the big debate is around costs and passive house costs. And we've done various studies and worked through elements of certainty with different design teams now around it not having to cost anymore. So, cost is a matter of priority. And I feel, and we've seen, and it's been proven that, it's really about that collaborative relationship with an understanding and informed QS that knows what they're pricing, that understands the approach that we're taking. And this is just an example of a recent study on several primary schools against our current one of our Passivhaus primary schools, where we're coming in under the Scottish Futures Trust current educational cost metric. So just to move on to the main focus of today's presentation, Curry Community High School. The client is City of Edinburgh Council. And City of Edinburgh Council have had probably quite a well-publicised journey towards better quality buildings and towards their learning around Passivhaus. So we had the Cole report published in 2018 after a series of performance failures in schools, and that led to a much wider review of Edinburgh schools, including some post-occupancy evaluation of several large recently completed ones, some of which we've been involved in, which highlighted various comfort standards, operational performance not being delivered, what was set at design didn't turn out into reality, the need for non-complicated MEP systems, and other quality questions that arose through this period where there was brick cladding failures, and there was other failures on schools that came out of a particular wave of procurement that they're seeking to resolve. And that's parallel to external influences, such as the ambitious policy targets set by Edinburgh and Scottish Government, the Scottish Futures Trust kind of enabling policy to deliver better quality, as I've mentioned. And actually just this year, Scottish Government have issued a net zero carbon public sector building standard, which actually also draws in embodied carbon as a target. And then lastly, there's a recognition of actually, of course, we need to be retrofitting first and promoting refurbishment as part of that story, which is to try and bring that big emissions target per metre square per year for their educational estate down to technically zero. So in relation to Curry, it's a tandem build school just on the southwest of Edinburgh, just by the Pentlands. It's designed for 1,000 students plus community use and library. And we also have a 4-lane swimming pool, which is also to be Passivhaus, and a total GIF of around just under 13,000 metres squared. And this is just a site plan of the existing 1970 school, which is categorised as condition C, with various kind of structural and physical issues and pedagogical issues, and that the council made the decision that they wanted a replacement new school. So the new school is going to be facing just south of the existing school, and there's going to be a new series of new outdoor play and education spaces, and reinforcing existing linkages across the site and wayleaves across the site with a very well utilised pedestrian walkway. And there's also connections to the north and south in relation to public transport. The massing of this project maybe isn't what you typically expect of Passivhaus. It just goes to show that, we can have slightly more complex form, which is driven by architectural pedagogy and community requirements, and still be able to achieve Passivhaus, which we'll go into in a little bit more detail. So we have the teaching block to the north. We have a community link that houses the library, cafe, entrance point and wayfinding point for the people that are entering from the east side. And then we have the sports and leisure facility to the south, which was driven by the requirement to have a little bit of solar gain into that swimming pool, which I'll come back to later in relation to Passivhaus. There was a huge amount of consultancy work on the educational side with the City of Edinburgh in relation to new pedagogical ways of thinking and linking different faculties and looking at various ways of applying different learning pedagogies within the plans as well. So the internal spaces are kind of held together by some large 2 or 3 story voids, a heller upstairs, and the faculties emerge out of that and have their own separate linkages and cross-referencing. There's an external teaching terrace, and there's an encouragement that the students in the curriculum will apply the awareness about sustainability in the project as in their school education as they move forward. In terms of material palette, we're looking at very natural, low VOC materials and very calm palette. So, you know, some of the post-occupancy evaluation of our schools has been that kind of how calm and ordered the space feels, and that there's not a distraction to education. I think we really want to hang on to that simplicity of approach for Curry as well. In relation to PHPP, so the Passivhaus planning package, this is just a diagram to explain, you know, how we look at the energy modelling. So I know, you know, you might have your services engineer will have their IES energy model that encapsulates the whole building. In the Passivhaus modelling, we look at boundaries slightly differently. So we actually have 5 PHPPs running for this school to denote the different temperature and comfort conditions. They all have slightly different requirements in terms of complexity. This is just a little bit of an internal sketch of our pool design at the moment, and I might just explain some of the more kind of passive attributes to this. So, you know, we do benefit from some south solar gain in swimming pools, which is a little bit of a turnaround compared to that emphasis of wanting just a north facing, you know, fully glazed or partially glazed facade on typical swimming pools. The evaporation and humidity and temperature profiles are also slightly different in a Passivhaus pool, and we look at not recirculating any air into the space either. So I know we're doing that a little bit more because of COVID, but there's various rules and approaches in terms of designing Passivhaus pools that don't allow that either. And then it's very important that the plant is located as close to the kind of deep end and where the balance tanks are, that the plant for the pool itself then isn't put miles away from the pool location, because as you can imagine, it's a body of very warm water, and the energy required to keep that warm and to pump and filtrate that water needs to be as efficient as possible. So that was really key in some of the development of the plans for this pool. In relation to just the form and approach to the energy balance with Curry, these are just some summary examples of the elements that we look at each iterative design stage. So in that kind of cyclical approach we talked about, where very early on we're identifying what the form factor of the main school is, and that then forms the fact that we don't need to maybe go to 0.15 or less U values. We can take an area weighting benefit from the large form factor and the large surface area to volume ratio and the efficient form factor of Curry as it stands. The glazing ratios aren't the idealized glazing ratios for a Passivhaus building, but you know, we have teaching areas to the south, so we need to make sure we adequately glaze those teaching areas and classrooms that are facing north, as well as making sure that the south facade has adequate glazing as well, so that we're not in any compliance issue with climate-based daylight modelling or any other ventilation or natural ventilation requirements that we're setting in the building. And we've stuck for the moment with quite standard triple glazing values, which we expect may develop as we move through the subcontractor or supply chain process. And just a little graph on the right then to describe the gains and losses. So, you know, we're trying to get that balance of the heating demand down as much as possible, ideally below 15. So that's what we're looking at, and that's balanced by the internal heat gains of the building. So we need to make sure we accurately predict and work with the engineer around unregulated energy demand, and also the solar gain benefit of the building, and being careful that we know we're not encouraging overheating with that solar gain consciousness as well. Another area that architects really probably don't engage in as much is around small power and appliances and kind of the energy power load of the building. So, you know, we go into quite a lot of detail as architects, don't we, around timetabling and flow of students and movement and, you know, how someone uses a building, but then actually the impact of those students and the timetable on the ventilation design, on appliance use, on power use, all needs to be tracked through the Passivhaus software as well. So that unregulated energy demand and then that expected energy demand from different parts of the school. So we go into that in quite a lot of detail. In terms of materiality, we're looking at kind of simple profile metal cladding with a brick plinth that follows the building around and kind of exposes itself at different points. So this is just one of our visualizations, .ele design from Edinburgh, showing the kind of integrated approach to the building where the entrance is highlighted by a change in metal cladding. And again, this is the Western approach, so it's a more secondary approach to the building where we have elements of the brick and brick bond changing, rising up from that brick plinth area to denote some of the larger scale spaces like the games hall and onto the teaching terrace. And again, this is just an alternate secondary view from that eastern entrance. And you can see that, you know, there's been glazing and shading considered on those elevations, depending on, that's our south elevation there. We have our east and west elevations with slightly reduced glazing and also appropriate shading to ensure we don't have overheating. So that was Curry, just as a story, and hopefully that's going to site early next year in the springtime. So it's really exciting, the biggest Passivhaus project currently in the UK, educational project at secondary level, which is really exciting. The other thing I want to touch on briefly was just EnerPHit. So, you know, there's that question out there, is EnerPHit, you know, the Passivhaus EnerPHit standard, is that possible at scale? And currently, as an example, we're delivering with a number of other partners, the Cambridge Institute for Sustainability Leadership, which is a full-blown EnerPHit project underway currently in terms of enhancing and retaining the existing envelope, but creating you know, a really strong, comfortable environment internally and getting full certification for the EnerPHit standard, as well as looking at lower embodied carbon materials. So that's currently on site and going quite well. And then lastly, just to touch on, I know we talked about new builds in City of Edinburgh's new plans. City of Edinburgh have also expanded on what their challenge is around zero carbon by 2030. They realise they actually have to address the current existing building stock and how they physically implement that. Where do you start? It's such a huge challenge. There's such an era of buildings that are built, different eras. There's also different typologies of buildings. So there's a huge kind of asset management review that we're contributing to, that we're feeding into. And the first step in that is to actually start doing some deep dive pilot study assessments. So we're looking at about 12 pilot projects with them to see how feasible it is to get down to a level of retrofit that would bring them closer to that zero carbon target. So again, we're looking at modelling heat losses, getting air tests, doing opening up works, getting thermal imaging surveys done to really understand the building. Because, you know, especially if we're dealing with heritage buildings, it's really important we get a really good grip on what we're trying to achieve. And we have a summary there just on the right of one of these nursery schools in Edinburgh as one of our first pilots of how poorly insulated it is, very poor air tightness and substantial thermal bridges and the other constraints around trying to retrofit this project. Without going into too much detail, this is just an example of our interventions that we're proposing benchmarked against the RIBA Sustainable Outcomes Guide. So, you know, really by the time we get to a middle of the road retrofit, an EnerPHit informed retrofit, option 3A or 3B here, we're really quite close down and beyond the RIBA 2025 targets for new builds, which is, you know, really exciting. And, you know, refurbishment is really the way forward, that Retro First campaign that we see run by DAJ and others. But also it's a complicated process. So how do we enable a client to have appropriate decision making or frameworks in place to allow that implementation to happen? And so we've identified various factors around cost, carbon, indoor health, and also heritage value that we need to be able to enable a client to make decisions on to allow that process to really be implemented for 2030. So really where we need to go from is the recognition of need to promote refurbishment, to actually enabling a framework to allow those targets to be actually achieved and benchmarked against the wider net zero carbon challenge, and create an informed, robust methodology, which we believe Passivhaus, as a methodology that's already proven for 30 years, can provide any client in that compliance path. And just to finish off, I mean, you know, in the past, we treated buildings very differently. It was a very elemental approach. We had less technology. Currently, at the minute, we're in this race to net zero carbon. We have this era of energy confusion. You know, what target are we aiming for? How do we understand the target? How do we implement the target? And we, you know, lastly, just to finish, feel Passivhaus, its fabric-first approach and simplicity in approach to design should be driving that new architectural vernacular that we should all be trying to adopt to create a simplicity in trying to achieve these ambitious targets. Thank you.
Thank you very much, Anne-Marie. I think it's really interesting to see how Architype is moving from simply, and it's not that simple, having the understanding of how to design first, you know, low energy and then passive house buildings, into that point of actually working out how to persuade others of the merits and explain exactly what's happening. And I guess that's where I want to come to, because you showed us some cost information at the beginning showing that certainly in Scotland, Passivhaus sat within targets. But then you showed us the school, which was a less simple form, as you said, than one often thinks is needed for Passivhaus, plus the challenge of the swimming pool. And I just wonder how easy you're finding it at the moment to actually persuade clients and potential clients that they can go with Passivhaus, given the fact that education spending seems to be about the most constrained spending that we have.
Yeah, absolutely. I mean, and I know the metrics between Wales, England and Scotland for spending on schools there's a kind of a wild variation in what those cost metrics set and what the expectations are. I suppose, you know, the Curry, due to its educational pedagogy, you know, had a certain drive, and of course the relationship with landscape and outside learning. You know, we couldn't just design a simple box on this site where, you know, the first principles would be try and keep the form as simple as possible. And by introducing a number of other corners, you know, you are introducing additional cost on the project, but that's regardless of whether it's a Passivhaus project or not. The same waterproofing, the same, you know, the same amount of kilometers of windows, whether it's a Passivhaus project or not, still needs to be implemented. What I can say is that I think really early engagement and collaborative engagement with the QS, you know, client side and contractor side, can really kind of eliminate and optimize the amount of risk that's priced on projects. So I think an awful lot of clients and design teams are put off at REBA stages 1 and 2 because of the huge amount of risk that's put on top of a Passivhaus project, without really those members of the design team being informed about what they're pricing or how they're pricing that risk. Now, you know, given that we're in this era of kind of supreme market volatility as well, where, you know, prices have gone a little bit haywire across all the main construction methods, I do think that close collaboration early doors, you know, on a project recently down south, we identified on a major project, you know, several £100,000, for example, where risk was priced in that had no justification for it. And I suppose, you know, we don't think as architects that that's part of our scope, but that kind of line by line analysis and trying to get more detailed cost earlier will remove a lot of that anxiety around higher costs. And you know, there is an element of risk. You know, many contractors still haven't delivered to Passivhaus, but many tier 1 contractors have different regions now that have started to deliver. And it was very engaging and exciting at the tender process for Curry to see how amazing the tier 1 contractors are responding in Scotland in terms of educating themselves, rising to the challenge, and ultimately cost is just part of a whole other set of priorities for the project to get delivered, in our view. And also, I think you look at the kind of net present value, the future of kind of the decarbonisation of moving from gas to electricity. The running costs are going to amplify hugely across these projects in the next 20 or 30 years, excluding what the market cost volatility on fuel prices is going to do, if we don't try and reduce the energy consumption. And I suppose that's the principle. It's looking at those two bit budgets together, that capital cost input and the operational cost of a building's life, and how you can actually get a return on that over time as well. And just to add, I mean, currently Curry, even with the Passivhaus pool and the complexity form, is sitting just under that cost metric as well. Subject fantastic. To obviously going to, so, you know, we had to rise to that challenge. I mean, Edinburgh set that challenge. You have to deliver this project within the current metric. So, we were under pressure from that, and we did go through some engineering value exercises to get that cost where it is. But we hope the integrity of the building, it's not compromised as far as we're concerned, or the quality of the building so far.
That's great, thank you. And I think that some of the issues you've brought up about running costs, etc., are going to be picked up in our next presentation. But before I introduce our last pair of speakers, I just remind everybody, please, that you can send in more questions. You'll have a chance to put questions to Anne-Marie again, to Adam, and to the next two speakers in our final session. So send them in and we will pick obviously the best and the most pertinent. And now I'm delighted to introduce Matthew Traub, who's an associate at Allies and Morrison, and Gwilym Still, who's Passivhaus Leader at Max Fordham. And they are taking us back to residential, but again, not perhaps quite the residential that one would expect. So I think Matthew's starting. Over to you, Matthew.
So hello everyone, thanks for attending. Gwilym and I are going to say a few words about the Cranmer Road student residential project that was completed in 2020 for King's College, looking in particular at the question of can Passivhaus construction become the new norm, going from marginal to mainstream. I'm going to start by talking through the brief and the values that underpin that brief, the planning context and the implications on design, before talking about some of the impacts on construction, before Gwilym runs through the fuel source, the systems and control, so the post-occupancy evaluation that's being undertaken, before summarising. The site itself sits to the west of the historic core of Cambridge, around a 5-minute walk from King's College's main campus. King's College is a client, our owner of the site, occupier of the site and developer for the project, and as such, as well as being concerned with the capital cost of the project, they also would like low maintenance, robust and long lasting buildings, and they're interested in value for money over time. Their primary role is to provide support for the students living within King's and studying within Cambridge University, and as such they've got a very important pastoral role as well as a custodial role for the buildings that they own and operate, and a desire to create a collegiate environment within which students can flourish. As such, they're interested in buildings that they can be proud of, spaces that are conducive to learning, and they really want to create a sense of community for that graduate community living on site. So the brief that we received at the start of the project was for a unified graduate campus working to a 100-year design life, creating really robust, long-lasting and high-quality buildings, very healthy spaces for people to live in and value for money over time. But what's interesting in this case is that there was no requirement for Passivhaus at the outset of the project. It was actually something that we came to at RIBA Stage 2 as we worked through the project and the brief, in particular looking at this challenge of a 100-year design life and what value for money meant in that context. So at a very early stage, we undertook a lifetime cost assessment looking at 3 environmental options: a building regs compliant option, a general low energy approach and a full Passivhaus approach, questioning what the implications of these different environmental strategies would be on the performance of the building, the construction of the building services, the lifetime of components in the building, the professional fees and risks. Now this informed the lifetime cost assessment, and for us was a really helpful tool in taking the client through the implications of the different environmental strategies. We find it a really useful method of communicating with the client, and these lifetime cost assessments sitting alongside lifetime carbon assessments are becoming an increasingly important tool in our communications with the client and with wider consultant teams. What this told us back in 2016 for Cranmer Road was that at that point in time, a Passivhaus approach represented a 20% uplift in the capital cost of the project. However, when we looked at it over a 60-year period, considering the cost of renewing equipment in the building, the operational costs and the reduction in maintenance costs, it actually represented a 2.3% saving overall, meaning that capital costs were recovered after 25 years, cost benefits were realised after 30 years, offering many, many years of value to the college as a whole. And on this basis, together with the qualitative benefits that come from a Passivhaus development, the client was happy to proceed on that. What we've seen subsequent to this is that actually the cost impact in terms of capital costs has come down with enhancements in regulatory standards and reduction in the perceived risk within the construction industry, reducing capital costs further, The Passivhaus Trust estimated in, I believe, 2019 that for all types of projects, Passivhaus represented an 8% uplift, but we found in very comparable projects in Cambridge recently that there's no significant difference between the capital cost estimates for building regs and for full Passivhaus projects. So we see that cost issue going away, not offering a significant impediment to a wider uptake of Passivhaus as a whole. So as I said, on the basis of our lifetime cost assessment, Passivhaus and a direct electric heating and hot water strategy was added to the original brief. Another aspect that significantly impacted the project was its location in West Cambridge and within the West Cambridge conservation area. Now, development within conservation areas is strictly controlled through planning. Planners need to balance the benefits of development within the conservation area against the potential harms of the conservation area. And on this basis, the original principle for development on the site was rejected outright. We had an initial planning application that was refused both at committee and appeals, so the subsequent planning application that was accepted needed to very carefully consider the conservation area, designing it sensitively to ensure that no harm was created to the wider conservation area through the proposals. Now, the particular location is the location is particular to this project, but this challenge is general within the construction industry. Within the UK, there are 10,000 designated conservation areas, taking up about 2.2% of the total land mass, meaning that the construction industry as a whole needs to grapple with whether Passivhaus can be adapted to respond to different conditions that require different aesthetic responses. Is Passivhaus a square peg trying to fit through circular aesthetic holes, or is it something that can be manipulated through detailed design in order to provide the variations in aesthetic that might be suitable for different locations? The aesthetic that was particular to this location was responding to the arts and crafts development that happened in the late 19th century, red bricks, white windows, clay roof tiles, which is very representative of West Cambridge as a whole. And this combines in West Cambridge with mid-century modernist buildings that came from typically collegiate and university clients. So the architectural approach that we took to the project sought to balance these two aesthetics that within West Cambridge are generally considered to sit well together, despite being so different in terms of scale, materials, detail and use. On this basis, we observed the site as it stood, containing two existing buildings, Cranmer Lodge and Grasshopper Lodge, both formal fronted arts and crafts villas, red brick, white windows, clay roof tiles, and tried to introduce a new villa building that continued the rhythm of arts and crafts villas along the southern side of Cranmer Road, looking onto Cranmer Road, filling what we perceived as a gap in the back garden of the Grasshopper Lodge site. Here we can see the completed buildings responding to the tones, textures and forms of those arts and crafts villas, red brick, white windows, clay roof tiles, and sitting in a complementary fashion with the existing buildings on site. And then to the south of the site, up against the leafy Leckhampton Lane, we introduced a distinctly different building, a building that was responding to the modernist heritage of West Cambridge, using white framed precast concrete facade to hold red terracotta baguettes that again gently touch on the tones of the arts and crafts villas, and windows providing light to study bedrooms. On the south side of the building, there's a captured courtyard around which common rooms and kitchens sit. And this is a view of that courtyard from Leckhampton Lane. On the corner most visible within the conservation area, we took the opportunity of stair to provide a slightly more playful aesthetic with a cantilevered precast concrete roof and glass-to-glass corner. And importantly, between these buildings, external spaces were framed, secret gardens, formal gardens, allowing everyday interactions between students living on site to occur, and trying to really create that sense of communities with kitchens and common rooms all opening into the garden spaces. Here within the garden building, a common room sitting between the principal garden space and the smaller courtyard. And here on the north side of the garden, a common room associated with the villa building. So the challenge for us through detailed design really became balancing this aesthetic, the expressed masonry facades and express structure, with the performance of Passivhaus, questioning whether that performance can be achieved with the aesthetic we were looking for. And what I'll do now to conclude my portion of the presentation is walk through a few of the details that were developed to try and achieve that performance while also achieving the aesthetic intent. starting at the foundations with the warm slab that was developed. This solution essentially is a floating foundation solution where a warm concrete slab sits above rigid XBS insulation that then bears down on the shared strip foundation around the perimeter of the building. This was developed in response to buildability requirements and also thermal requirements. This is a thermal analysis of that detail, confirming that it actually provides a thermally bridge-free method of construction. And when we looked at the energy savings that would be associated with that, we identified a figure of 3.9 kilowatt hours per metre squared per year, which actually in a passive house project represents a significant amount of the annual heating demand, a quarter of the annual heating demand. So this quite invisible and subtle detail unlocks a great improvement in terms of the energetic performance of the building as a whole. And here it is on site with sand blinding, XBS insulation, damp proofing and formwork for the concrete. On top of this foundation solution, we located a low carbon CLT superstructure for the building. We employed this as the principal airtight line for the building as a whole. Now, obviously in passive house buildings, airtightness is incredibly important. So we use this CLT simply by taping the joints between panels and taping the windows into that CLT structure. This had three benefits. First of all, it ensured that the responsibility for the airtightness sat within few subcontractor packages, the provision of the CLT and the provision of the windows. Secondly, it meant that at a very early stage in construction, we could get an assessment of the airtightness of the building as a whole. And finally, it meant that the airtightness line itself was incredibly robust, so follow-on trades were unlikely to damage or penetrate the airtightness line. And for these reasons, we achieved an incredibly low airtightness level for both buildings, 0.16 and 0.19 air changes per hour, significantly better than the 0.6 maximum that passive house works to. The final point I'll make is about how we supported the quite heavyweight masonry facades off the CLT structure itself. Obviously, on typical buildings, you'd expect a significant amount of secondary steel work to tie that external cladding back to the superstructure. But in this case, we took the load straight down onto the shared strip foundation at the bottom of the building, just employing lateral restraints to stop that exoskeleton from essentially falling forwards. This is some of the bracketry being installed, and another benefit of it was that we could insulate the entire facade before the external cladding was installed. This meant that we could check the quality of the insulation before any external finishes went on, and then the external finishes themselves were very simply installed in place sequentially. And here's the eventual effect. So what we discovered through that design process really was that Passivhaus didn't represent any impediments for the aesthetic effects that we were looking to achieve. It offered a series of principles to work to, a series of tools that we can use to check we're going to achieve the energetic performance and some targets to work to. But then design really could start in terms of the detailed design for the buildings. I'm going to hand over to Gwilym, who's going to talk through some other aspects of the scheme.
Thanks, Matt. So I'm going to have a run through then of some of the high-level decisions we made for the scheme, particularly around the choice of fuel source, some of the medium-level decisions around system strategies and things like that, and then one or two examples just down at the detailed level of component selection, a brief discussion about some of the post-occupancy evaluation we've carried out, and then our conclusions and reflections on the scheme as well. So the first one then is a choice of fuel source. So coming into this, we knew that Kings are a good client and are used to holding buildings and maintaining them for a long time. And so we're looking at the carbon intensity within the UK of electricity versus gas. And we've got the graph here is showing both the, you can see the historic trend of figures of carbon intensity of electricity dropping. You can also see in the dark blue the projected intensity of electricity going down to something pretty low in the future. And when you compare that to gas, which is likely to be pretty stable, all hydrogen discussions aside, then it was clear that around early to mid 2020s, you get a tipping point where electricity was lower carbon than gas. And this is the building design life. So even if at initial handover, electricity would have been a higher carbon fuel source, for the overall life of the building, electricity made much more sense, and that's why we went for it. Interesting, this is the carbon intensity that building regs would have us use in compliance modelling for electricity at the time. So it was only really the very low energy consumption that Passivhaus has, which enabled this as a strategy. We wouldn't really been able to do the same thing on a conventional scheme. Then for some of the individual services strategies, so for domestic hot water, we're interested in several things really. We wanted something that was simple, that minimised distribution losses and the risk of overheating, obviously used electricity, and that limited any wastage as well as minimising demand. So we went for a strategy which has point of use instantaneous water heaters, micro bore pipework running out in radials to each appliance, low flow sanitary air, particularly the showers were less than 6 litres a minute, and that was followed through into wash hand basins and so on. And then wastewater heat recovery as a simple passive means of recovering some of the waste energy that would otherwise have gone down the drain. For the ventilation side of things, again, we try to keep things simple. There's two different strategies for the different characters of the building and the different usages of space within them. So for the villa building, we've got something which is very much like the cascades type system which you would have on a Passivhaus house. So we're serving the building, which is 19 bedrooms, with 2 of these domestic scale ventilation units. And on a typical floor plate, that means we're supplying fresh air into the bedrooms, we're transferring that air from the bedrooms into the communal corridors, and then we're pulling that air from the communal corridors through into the places which need air extracted from them, so the toilets, the WCs, the store cupboards, and the kitchens as well. That approach has let us then limit the total ventilation rate that we need for the building, and it's also let us serve the whole building with a couple of units and some very, very simple controls that just run at a fixed flow rate. The garden building is slightly different because we've got all of the bedrooms there have en suites, and so all of the en suites need extract ventilation from them. So the general approach there for a typical student bedroom is we supply fresh air into the bedroom, we transfer it through a door undercut into the shower, and we pull the air out of the shower. And we've gone for a decentralized system here, so the cyan blobs you can see across here represent the locations where those MVHR units are, just on the top floor. And again, we've gone for 2 different models of domestic style ventilation units here, again with fairly simple controls. So there's 3 of these ones which do the common room and the kitchens, and then there's 10 of these individual units which serve groups of clusters of 4 bedrooms. For the space heating side of things, we wanted both to limit the impact on space within the building and also provide something that's very simple and cost effective, so that the money the college was spending went directly into the building fabric and the things that are going to last over decades. And so it's our minimalist slide. We've got electric panel rads with very simple localized controls. One of the details, this is an illustration of a wider principle we found interesting, was really looking at the energy consumption of kind of ancillary mechanical and electrical systems, which doesn't normally get dug into that much. So for the access control systems, we looked at those and looked at what we thought their operational energy consumption would be. Here's a couple of figures showing you a kind of typical Passivhaus heating energy limits and an indicator of the total energy limit for the building. When we spoke to the incumbent access control specialist and asked them to estimate the energy consumption of the access control system over a year, they gave us something like this. And after we concluded that we couldn't really heat the building through access control, we did some separate calcs based on information from another manufacturer and got to a figure somewhere more like this. So obviously that's a lot lower, but it's still, you know, around 1/3 of the heating energy for the building and a reasonable chunk of the total energy use. So we redesigned that system to get back to a wireless system, which brought us down here. So you know, we're down at about 2% or so of the annual energy use of the building. And we thought that's, you know, it's a nice example as a particular scheme system, but it's also illustrative of a wider point that as we manage to drive down things like the space heating demand, domestic hot water and so on, it's also important to focus on these other and normally considered ancillary systems and look at the energy use of them to see if it's significant or not. And so we followed that through into things like fire and smoke dampers, hot pockets for lighting control in rooms, and contactors for windows and heating control systems. We've carried out post-occupancy evaluation on the building, both from taking meter readings and evaluating them and comparing them with weather data, and also from using a bus methodology survey and obviously direct feedback from the clients. For the POE, this is the Passivhaus heating power limit, so 10 watts per square meter, and that's tested in PHPP, the design tool, against 2 different weather conditions. So a cold sunny winter's day, shown here, where it's pretty cold but you've got some sunshine coming in and warming up the building, and then a slightly warmer but still cool day where it's overcast and there's very little sunlight around. We found the day with the highest heating power consumption. This is what the outside air temperature looked like on that day, and so the average was between those 2 conditions, so we thought that was a fairly good test. And we've got from the electrical meter data that's available the hourly heating loads, which is averages out to about just under 8 watts a square meter. So we're happy from that. So actually it's demonstrating the reality is matching up to the modelling and the predictions. We did find one challenge, which was the feedback from the college that the student expectations in wintertime were flip-flops, shorts, t-shirts, wandering around and wanting the temperatures cranked up a bit higher. And also we had some feedback around shower durations, where I think the PHPP assumptions for shower duration are not entirely accurate for a community of graduate students. So there's plenty who had 20-minute plus showers, and we knew that because the run-on the presence detector in the en-suites would turn the lights off after 20 minutes. We've compared then the energy consumption against both some industry benchmarks at the top in grey, other precedent projects that we found data for, so these are real individual buildings, and then in orange here some of the climate emergency targets, so the LETI targets from the Climate Emergency Design Guide and the RIBA 2030 Climate Challenge for a non-domestic building. Obviously the comparison has been complicated a bit by a global pandemic sweeping around while we've been taking the metering and the building usage changing. We think that we're somewhere in this range here between the kind of dark green and the light green. So either hitting those LETI and RIBA targets or basically at as good or slightly better than all of the other precedent projects we've been able to find. And the overall feedback from the students has been very positive. So this is one of the responses from the that bus methodology guides, giving a view on overall comfort within the building. So the higher the number, the better the contentment. So I think that brings us on to our kind of reflections and conclusions. On the cost side of things, which often gets talked about, we found on other recent projects, cost isn't as much of an obstacle, and actually the lifetime costs are lower and the capital costs are becoming much lower or neutral. Passivhaus gives us some principles, tools and targets then, but not a prescriptive style, and so it's been compatible with these really challenging planning conditions. We've achieved Passivhaus using largely standard UK construction materials, so there's options for scaling up there. We're not using something that's very esoteric and only rarely used. We've delivered an all-electric scheme, and there's a number of ways of doing that. It's been delivered with a design team with limited experience, so I think it was Allies and Morrison's first project, it was Smith & Moore, the structural engineer's first project, it was one of our first, not quite the first, but very early. Passivhaus has been good because it's promoted this early analysis of buildability and sequencing, and it hasn't relied on experienced main or subcontractors. So several of the key subcontractors involved in the scheme didn't have Passivhaus experience beforehand. They still delivered that excellent air tightness that Matt showed earlier and all of the other things that go with it. And also from some of that POE, it's difficult to accurately predict human behaviour. So I think our kind of response to the initial question for this webinar was saying, well, yes, Passivhaus can and will go mainstream. If we're going to hit the climate emergency targets that we're setting, then that's needed. And the interesting discussion to go with it, I think, is what else do we need to be doing to deal with things like soft landings, embodied carbon, etc. So just before we wrap up, we'd like to say sort of thanks to a lot of the other collaborators on this scheme. Matt and I are only part of a much wider team. So Kings is the client, RG Carter is the main contractor, Warm is the Passivhaus certifier, Smith & Moore structural engineers, and Faithful and Gould, who are the QS and the project manager. So thanks very much. If people have questions, then we're happy to either field them now or take them later on instead. Thanks.
Thanks very much indeed. I'm just going to put a question to the two of you, and then we will move on to our discussion. I loved that, and I'm going to actually focus on something which at first sight seems quite amusing, but I think is quite profound. And these are the 20-minute showers. I mean, how much do you think, once one moves beyond the individual home, where people's behaviour, one imagines, is to an extent driven by having to pay the bills themselves, how much do you think one starts needing to look at behaviour management in order to actually get the performance out of the building that you want? I'll put that over to either of you. And obviously, I guess it's can the design of the building actually force people to behave differently, or do you have to put an alarm in and say shower going off in 30 seconds?
Maybe I'll say a few words to start, Gwilym, and then you can pick up anything else. But I find this area quite an interesting subject and a challenging subject, because for me, it shouldn't be about behaviour management. You shouldn't have buildings which determine how people behave within them. In fact, the buildings should be designed in order to facilitate behaviour and to enable people to live in those buildings. And so what I like about Passivhaus, and what I think Passivhaus does very well, is it designs very high quality, low energy buildings that are comfortable for people to be in. It's a comfort driven standard. It's reliant on creating on minimal levels of overheating and working within thermal standards. And so actually what it does is it makes it easy for people to live within those buildings. Now, there are some students who like to have 20-minute plus showers, and we know the college are gently encouraging those students to take shorter showers. And as you say, in a domestic property, obviously people will be managing the energy bills, and as we move through into the future decades, we know energy is going to become more of a consideration, and people we anticipate will be more aware of that. But fundamentally, what Passivhaus is doing is driving down the energy use generally. So if people do choose to have 20-minute stands, it doesn't have such an impact, or you're coming from a very low base in terms of energy use. I don't know if there are any other points you want to add to that, Gwilym?
I think that's right, and I think we are trying to we try to provide some more feedback to King's so that they can talk with their students about what the energy uses within the building are, what the most significant ones are. We've had chats with some of the students, and some of them said they ended up taking the lights dimming in the bathrooms as a good prompt, that they'd had a fairly long shower. And on some of the other, for things like the heating controls here, I think for the next iteration of the student projects we're doing with King's, we're sort of shifting the balance point slightly. So where we'd tried to keep the heating controls and everything really, really simple for Cranmer Road, we're giving the students a partway house where they have some localized controls and can do a boost to the heating for a limited duration of time, and then it'll return back to the standard temperature setting. So there's that kind of balance point in there between some local autonomy, which gives people a better enjoyment of their space, but also not letting students create saunas in their room. And I think there was also some work about, again, we kept the energy metering quite high quality data, which can be analysed afterwards, but quite simple in terms of what's presented to the students. And in some of the other schemes, we're now doing a kind of more localized thing where we can present energy data back to the students on a kitchen plus cluster of bedrooms basis, and try to encourage a bit of friendly competition between different kitchen groups of students, so that there's it's not kind of completely anonymous and they don't get any feedback about how they're impacting the building's performance.
Thanks so much. We're going to move on in a second to our group discussion, and so we'll see all the other people joining us on the screen here. Just before I put any questions to them, however, we've heard a lot about innovation today, and I just want to remind you about another chance to hear about innovation, which is taking place tomorrow. It's the third in Schu UK's popular Innovation Now series. It's I Now series. And it will be tomorrow at 10 o'clock, looking at how successful building design demands innovative products and systems that meet all the safety requirements without compromising on aesthetics. The reason I'm telling you about it now is I'm going to give you the web address now, but I'll give it to you again at the end just in case you haven't had a chance to note it down. And it is www.schuco.com. Schuco is spelled not with the umlaut, it's SCHUECO. So it's www.schuco.com/UK/INOW, which is spelt INOW. So I'll give you that address again at the end. It's well worth going. But I'm going to come on now to our panel discussion. Everybody's here. And I've had some really interesting questions coming in. Someone's saying, how do you weigh up Passivhaus ambitions with net zero carbon targets or embodied carbon? And particularly questioning on the project that Adam showed, the use of glass fibre reinforced concrete, which they say is inherently high carbon. And somebody else said, this is a heavy building. And the planters as well make it even heavier. Now, obviously, we've seen a lot of brick on that great Allies and Morrison scheme. It's a complex question. And I'm going to put it, I think, first to Anne-Marie, who I know has some strong feelings about some of these issues.
Yeah, I mean, I think the whole picture of sustainability, I mean, Passivhaus just really at the moment is dealing with the operational side of net zero carbon in use. And I think I think we referred to at the end of the slides, and we're in this era of energy confusion and how to prioritize what energy emissions that we need to be targeting. The idea around trying to reduce embodied emissions also kind of has a huge level of kind of controversy out there. Like we found in studies that when you look at longevity in terms of embodied carbon, sometimes a small amount of those higher emissions materials are actually more robust over the 100-year period rather than some of the more natural or low emissions in relation to the initial kind of A to D of the cycle of embodied carbon emissions. And I think it's about having the right tools to be able to kind of help you make those good decisions. I think it was obvious in Cranmer Road how there was an embodied carbon approach there that was complemented the operational approach really, really well from Gwilym's, the POE results. So I think they can all sit and reside alongside each other. Really well. It's just about having the right tools to know what you're doing and be able to understand what part of the carbon cycle you're trying to reduce or look to kind of mitigate as much as possible. So I think it's a very layered question, and I think we all just throw around the comment about net zero carbon without really understanding. Even clients don't really understand what it really means, and we have unregulated and regulated energy demand, and some of our compliance rules and legislation only refers to regulated energy demand, and the standards like Letty, Clara Bagnall George and others that are doing so much work out there trying to activize the construction industry to be more aware about what those targets really mean. Don't know if anyone else wants to add to that maybe more specifically.
Well, I'm going to ask Adam if you've got anything to say, because that was specifically addressed to your project, I think.
Yeah, I think there's an interesting balance, as Anne-Marie said, where we're looking at products and specifications that respond to the parameters of Passivhaus and energy use, but offsetting that design life. And obviously, in the context of that project, we could look at using a concrete material and therefore then looking at offsetting, which would be let's say an easy way out, and I think what a lot of people do. But actually, what we're looking at doing is upskilling the concrete suppliers on island. So looking at how we can work with them to set the new benchmark for the supply chain in the locale. So and how we can bring in recycled content to that material, and how how it can be as efficiently designed as possible with the engineers to be as lean as possible. And then also how that then is overlaid so that it becomes part of the architectural finish. So instead of us having layers of other materials that are also, other virgin materials, it's about how we can use one thing for multiple things. So it's structural, it's a weatherproof item, it's also a recyclable item, and bringing all those things together really, so that we can minimize other material uses. So it is looking at it more holistically rather than just a kind of oh, it's concrete therefore it's bad. And that's kind of how we're responding to it on Ireland. And again, rather than offsetting, using it as a means for upskilling to hit that new benchmark and 2030 target for Jersey.
Thank you very much. I've got a question which I think is probably most relevant to Matthew and Gwilym, which is with COVID possibly being with us for some time, we couldn't get through this without having a COVID question, but I do know it's very relevant. Has there been any rethinking of ventilating bedrooms, etc., out to communal corridors, which on the face of it would appear to promote cross-contamination?
We've seen bits in some of the draft guidance for the next iteration of approved document F, which would push you away from doing that kind of communal space ventilation. But I think there's also a point in there, which is the general approach for the Cranmer Villa and so on would mean that the transfer through to the corridor and the extract from the kitchens and so on would, so one, it would be reliable ventilation at a good rate to provide dilution, and that's generally what the ventilation approach for COVID risk transmission is addressing, is risk reduction through dilution. But also it's people who are tending to socialize together to an extent and live within the same space, so there's a risk of that transmission regardless. But I think we are seeing a bit of a move away from it in some of the draft documents. I think that gets particularly interesting for some of the larger buildings, so particularly schools and things like that, which have frequently been done as passive house schemes in the past with a whole building cascade approach and supply into classrooms, transfer and extract from halls and centralized spaces.
That's really interesting, thank you. I've also had someone asking, again, at one level this looks simplistic, but I suspect it isn't. We're all going to go all electric. Where is all the electricity that we're going to be using coming from? Now, obviously, I know we're talking about reducing our power consumption, but I think it is quite interesting. And forgive me if I'm wrong, but I don't think I saw a single PV panel on these projects, did I? Are we really moving away from any kind of on-site generation? I think I'm going to put this to Anne-Marie first.
Okay. Well, we do have a minimum requirement for a certain amount of renewables on Curry that we showed you. So there is an element of offsetting, and we can get into very protracted debates about how much embodied carbon actually PV panels themselves have, and how much they need to offset themselves also. But in terms of having a fabric first approach and reducing the energy consumption, an element of renewable energy and generation on site, I think is a positive thing. What's not positive is that if we don't diversify and really interrogate the loads, as I think kind of Gwilym's presentation showed really well, that you can really challenge hot water loads, and the latest guidance, which is a little bit outdated on diversified loads for hot water, for example, that CIBSE are addressing, I believe, this year in new guidance, that we can really drive down what the actual real demand is. And what we found on sites recently is that the KVA demand, so that substation that's built to cater for that electrical load coming into a site, is sometimes triple the size of what the operational profile of that school is. What's going to happen now is the heat networks and the utilities bodies are going to get fined if they start putting in, massively overspecify electrical loads coming into buildings. So again, it's not something maybe that the architect typically picks up or is even interested in, what's the size of the substation. But ultimately, the bigger picture is, as we decarbonise and as we use more electricity, exactly as you've said, Ruth, we need to be much more mindful of what the actual consumption is. And that reference that I've made about the KVA, the substation, being 1/3 of what the building consumption is, that's not even with the passive house building. That's just a kind of, building in the last 5 years, profiling the incoming energy into that building with on a heat pump system, actually, in that particular example. So I think, again, challenging that usage profile and what we typically design to what we actually need. It's a challenge. We will be questioning guidance and legislation, but post-occupancy monitoring is proving in many situations, as we've just seen, that consumption can be significantly reduced, and therefore the sizing or oversizing that we typically do to, in the industry anyway, we need to interrogate that.
That's really interesting, and I just say that I was also fascinated by listening to, I think you made reference to small power, and listening to Gwilym talking about the access control system, and the fact that our eyes have sort of shifted, first of all, from energy consumption. Then, of course, as we got that down, we looked at embodied energy, and now we're looking at all those ancillary things in the building, which probably a few years ago we didn't even worry about. Now Absolutely. They are becoming so significant. And I think what is great is that there are people like you four and a lot of others out there thinking about it. And there's a whole audience out here listening, sending in questions. So I think as an industry, we're really engaging. I'm going to wind up in a second. Before I do, I'm going to give you that web address again for the Schuco iNow event tomorrow morning, which is, their web address is www.schuco.com. That's SCHUECO.com/UK/INOW. So highly recommend that. But now I'm going to draw this to a close. I just want to hugely thank our speakers on behalf of Architecture Today and of Schuco. You have all given us so much to think about. I'd like to thank everybody for attending and for all your questions. Look forward to seeing you again. Thank you. Bye.